Hello everyone, welcome to my chemistry channel B.L.DASH short and sweet in chemistry. Now I am going to explain coordination compound, the chapter for 12th science, and it is according to CBSE syllabus. Here that is part 6a, isomerism in coordination compounds. Then question is, what is isomerism? Now it is related to coordination compounds. In organic chemistry also we read the isomerism, different type of isomerism, how it is related different in different isomerism. Now also we will see here the isomerism in coordination compounds. From part 1 to part 5 I have already explained regarding ligands, different point coordination, number, oxidation number, coordination sphere, like this I have completed. Similarly, I have completed that naming of ligands and naming of the coordination complex. I hope it is clear to you. When please one request to you all, when you start to read the coordination compounds, start from part 1. Part 1, part 2, part 3, and after that part 4a, b, c, d, and also 5a, b, c. Please, after that you read introduction to isomerism, because already all are related in different way. So please start from part 1 and continue up to 5c, part 5c. Now here part 6a, because here I am going to explain the topic isomerism. So first of all, you see what is isomerism. What you know in your organic chemistry is same molecular formula but different arrangement of atoms. What is mean? Different arrangement of atoms. Here also you can see coordination compounds having same molecular formula but different structure, different arrangement of atoms mean different structures, or spatial arrangement in space. You know, if coordination number 6, the structure is octahedral. If coordination is 4, maybe tetrahedral or square planar. That means it depends on the spatial arrangement of atoms. If atoms are arranged in space, that is spatial arrangement. That means here what is isomers? Arrangement of atoms, that is different structures or arrangement of atom in space, and then it is called isomers. What the structures form, that is called isomers. Then what is isomerism? Isomerism means the phenomenon how to form the different isomers, possible isomers, that is called isomerism. I hope it is clear. Isomerism means the phenomenon how to produce different isomers, that is called isomerism. Isomers mean different structures or different arrangement of atoms in whether it is in the form of structure or in the form of spatial arrangement in space. Then come to, that is why since the arrangement of atoms are different, they should show one or more physical or chemical properties, they are different. That means due to different arrangement atoms, that is structure or spatial arrangement, they have shown the different chemical physical properties. They may be one or more. Sometimes one coordination compound that we have isomers, they shows different, one may be one chemical property or two chemical properties or two physical properties, like that. Two types of isomers in coordination compound. In also organic chemistry also, there are two types of isomerism. One is called that is structural isomerism, and other one is called stereoisomerism. What is meant by stereoisomerism? Stereo means in space the arrangement is different, and structure means in structure the arrangement is different. In stereoisomers, there are two possible chance. One is called geometrical isomerism and second is called optical isomerism. And what is geometrical isomerism? What is optical isomerism? Individually, I will explain regarding geometrical and optical isomerism. Then come to structural isomerism. Structural isomerism are four types. Then I will explain what are the four types. Again, see, isomers mean different arrangement of atom in space or structure. If space, that is called stereoisomers. If structure, that is called structural isomerism. Structural isomerism are four types. That is, they produce what are the change in isomers. They are called isomers because they have different structures. That is why they are isomers. The phenomenon how to produce different type of isomer, the process, the phenomenon is called isomerism. I hope it is clear. And why that there is different chemical and physical properties? Because due to different arrangement of atoms. Now we will proceed to what are the structural isomerism. Though you know four types, now I am going to explain what are the different types of structural isomerism. Structural isomerism. What is structural isomerism? Where structures are different. Structures of different mean different arrangement of atom in structure. That is called structural isomerism. Now structural isomerism are four types. Number one, linkage isomerism. Number two, coordination isomerism. Number three, ionization isomerism. Number four, solvent isomerism. Now we will see one by one and only the summary, only the meaning of linkage isomerism, coordination isomerism, ionization and solvent isomerism, and after that in coming video I will explain one by one in detail. What is linkage isomerism? From this word one can imagine the link between something is different. Link between what is the different? Link between central metal atom and ligand, that is different. That means which atom is attached to the central atom, central metal atom is different in two cases. Just example C and cyano. C will attach, that is called cyano. If N is attached here, if N is attached then isocyano. Then here if N is attached then isocyano. If C is attached then cyano. Again see, linkage isomerism means link between central metal atom and your ligand is different in which through the specific atom. If example C and C attached, then it is called cyano. If N attached to central metal atom, then it is called isocyano. Coordination isomerism. Coordination means the coordination sphere. The coordination sphere, the central atom if exchange, then interchange of ligands. If ligand exchange in two coordination spheres, let us example, simple example I want to tell. Coordination number of cobalt and chromium both are 6. That is why coordination ligand, that coordination number 6, ligand 6. Coordination number 6, ligand 6. But what happened? Here you can change water here and chloride here, then it is called coordination isomerism. Here you can see one part is +3, other part should be -3. Sorry, it should be -3. Then only you can say coordination isomerism. Ionization isomerism. What is meant by ionization? In coordination sphere, the complex ion having superscript positive, that is called complex, cationic complex. After that you see some ions are there which are called counter ions, and that will give what test? Acid radical test. If you can say inside the coordination sphere, one ligand will go to outer side and act as counter ion, and outer side counter ion will come to inside the coordination sphere. Ionization isomerism means counter ion and one of the ligands should be exchanged. You know what is meant counter ion, which will give acidical test, that is outer side the coordination sphere. But what anions are present inside the coordination sphere, they never shows any acidical test. They behave only ligand. So ligands never shows acid radical test. But outside the coordination sphere, what is present as anion, that will give acid radical test, and that is called counter anion. Now see, if Br minus as a ligand inside the coordination sphere, if it will go outside, it will act as a bromide ion, counter ion, which is act as a acid radical. Again see, ligand can be displaced by a counter ion. Which is counter ion that go inside the coordination sphere, which is a ligand, it will go to out, act as a counter ion. Then solvate isomerism. Solvate what? Solvate what comes from water. That means what is the water molecules present inside the coordination sphere, and what is the water molecule present outside the coordination. What is the difference between two? If inside the coordination sphere water molecule is there, that is called what? Ligand. That is aqua. What is the name? Aqua. But water molecule is present outside the coordination sphere, that behaves only as water molecule. On heating, these water molecules can evaporate. Why? Because it is free. But when inside the coordination sphere, that is not free, that acts as a ligand, that should attach to central metal atom, that is fixed to the central metal atom. That is why that never act as a free molecule. You can't evaporate it can't evaporate the water molecule which is present inside the coordination sphere, because it acts as a ligand. But what is present outside the coordination sphere, that will act as a free water molecule which can evaporate on heating. Gradually the water molecule decrease also on heating. This is the difference between solvation isomerism, ionization isomerism. Ions are displaced but act as a counter ion outside and act as acid radical. And water molecule, it go to outside, that means it behave as a free water molecule. Similarly, coordination isomerism, where here the ligands can be exchanged between two coordination sphere. And linkage isomerism means the link of the atom towards the central metal atom can be changed, can be exchanged. Here you can see one side C and cyano, that means C is attached to central metal atom, whereas N is attached to central metal atom. I hope it is clear. In coming video, I will explain individually linkage isomerism with example, similarly coordination isomerism with example. Now only it is the introduction part, so next we will continue each one and individual with different examples. And hope you will subscribe my channel B.L.DASH Short and Sweet Chemistry. Also hope you will like and share my channel to other students. And thanks for watching my video. Thanks again to all.